Today's lesson comes from Chapter 3, Lesson 6. It's the distributive property. I call this the number addition, as tomorrow we're going to still look at the same section, but we're going to look at the distributive property with algebraic expressions. But for today, just with numbers. And our goal then is going to be to use the distributive property to create equivalent expressions. We're also going to use the reverse distributive property. By the distributive property, what I mean is that the product of a number and a sum or difference is equal to the sum or difference of the individual products of the addends and the number. So what this does is it shows us how multiplication affects both addition and subtraction. So what this means, when I'm given a problem like 8 and then in parentheses 4 plus 6, I notice right away that the 8 is right next to the parentheses. There's no operation sign shown there, but just like when I have a letter right next to a number, like a variable next to a number, and that means multiplication, the same thing happens here. So I'm really multiplying 8 by this total sum. We know one way to get that answer. Using the order of operations, we would do 8 times 4 plus 6. We would do that part in parentheses first, because parentheses come first in order of operations, so 4 plus 6 would be 10, and 8 times 10 would equal 80. So I know the value of this expression should be 80. The distributive property gives us another way, shows us how these numbers relate. The reason we take a look at it, when you might be asking yourself, well, Miss Prita, why do I even have to look at another way to solve this problem? I can do this 4 plus 6 and then times that answer by 8 really easily. Why this is important, or when it's going to be important, is for its connections to algebra, which we're going to look at tomorrow. So today we're working on this with just numbers, but when we work on it with algebra, we won't be able to solve. We're going to have a variable there. So we won't be able to get a simple whole number answer like we did here. So the distributive property is simply a statement of how these numbers can relate in another thing that they can mean. So we want to use that. We're not actually getting the answer, but showing what the distributive property looks like. So if I do or use this property, what it really means is I'm distributing the 8 to both of the addends, so both my 4 and my 6. What that does for me then, that multiplication symbol that I understand to be where that parentheses is, tells me that I should do 8 times 4, and I'm going to add whatever product I get there to the product I get when I do 8 times 6. Because remember, my distributive property told me that the sum or difference of the individual products. So I found two individual products and I'm going to find the sum of those. So 8 times 4 I know to be 32. I'm going to add that to 8 times 6, which is 48. And if I add those together, my answer would be 80. So notice I get the same answer, which is important. We know that those are equal, solving it by order of operations or using the distributive property. Again, the reason that we need to know this distributive property is for its applications to algebra and the things that it allows us to do when we're solving some equations and things in algebra. The distributive property also works when we have a difference, and it's going to work the same way. Again, I'm going to solve it first as I would with order of operations, just so I can show and compare how this works. If I use order of operations, I would do in the parentheses first, so I do 7 minus 5 is 2. I'd multiply that by 9, so I'd get 18. The distributive property, though, allows me to multiply the 9 times the 7 and the 9 times the 5 and find the difference of those two products. So if I do 9 times 7, I know to get 63, and if I do 9 times 5, I'm going to get 45. If I find the difference of those two numbers, 63 minus 48 is going to be 18. So notice again, I haven't changed anything, I'm just rearranging or showing my numbers in a different way. What the distributive property allows me to do is find what I call equivalent expressions. Equivalent expressions have the same value. They are the same number regardless of which number a variable stands for. So again, this definition is catered more towards the lesson we're working on tomorrow, but it works when we have numbers just as well. So to give one more example of the distributive property, if I take a look at this pair of numbers, and I want to show that it's equal to what we get using the distributive property. Again, using the distributive property, I'm going to distribute that 3 to each of my addends. So I'm going to do 3 times 8 plus 3 times 15. Notice on the other page I had parentheses there. The parentheses just help show me what I do first, but using the order of operations, I know how to solve this equation, or this expression on the right side here. I know that multiplication comes first, so I have to do the 3 times 8 to get 24. I also have to do my 3 times 15 to get 45, and then I'm going to get 69 as my answer. Solving the other way, I would do the parentheses first, so I'd leave the 3 in the parentheses. I do 8 plus 15 to get 23, and then I would do 3 times 23, which is going to be 69 as well. So notice I have a pair of equivalent expressions. A number times a sum or times a difference is going to be equal to, or an equivalent expression to, the sum of the individual products. I also want to be able to factor a numeric expression. This is also called the reverse distributive property, or the opposite of the distributive property, because I'm going to start out with no parentheses and just a sum or difference, but I'm going to finish up with a product of a sum or difference in parentheses times a particular number. So these steps are going to help me to accomplish that goal. The first step asks me to find the GCF of the two numbers and write this number in front of a parentheses. So notice 5, 20, and 8. I remember from a previous lesson that I have 3 methods of finding that GCF. I may even get to the point, because a lot of these are going to be pairs of smaller numbers, where I can simply find the GCF without even showing anywhere to determine the GCF. If you can do that, by all means, take a look at the numbers and choose the GCF. Just be careful to be sure that you get the highest factor that they have in common. I'm going to show your work, which you're also welcome to do for any of these problems, just in case you aren't sure what the GCF is, or you want to be sure and check your answer. So I prefer the birthday cake method, so I'm going to start out with my 20 and 8 in my first layer of cake. I know that 2 is going to go evenly into both of those numbers, so I'm going to get 10 and I'm going to get 4 when I divide the 2 in. And I'm going to notice that both numbers are still even, so I can pull out another 2. I'm going to get 5 and 2. At that point, 5 and 2 are both prime, so the only number that are going to go into are 1. My GCF is going to be the product of all those numbers, so I'm going to get 4. So 4 is my GCF. It told me in step 1 to write this number in front of a parentheses. So I'm going to say that 20 plus 8 equals 4, and then I'm going to put that number right in front of or next to the parentheses. You're welcome to put a multiplication symbol in if you like, but that is not required. We know that a multiplication symbol is understood to be there, so I can leave it just like this. Then it asked me to divide the GCF, so in this case, my GCF was 4, into each part of the expression. So I want to divide that 4 into 20, and I want to divide that 4 into 8. I'm going to put each quotient inside the parentheses. So if I divide 4 into 20, I'm going to get 5. And if I divide 4 into 8, I'm going to get 2. Now, step 3 says that if the original operation was addition, you place an addition symbol between the quotients. If it was subtraction, you place a subtraction symbol between the quotients. Since my original problem had an addition symbol here, I'm going to throw an addition symbol in between those, and I'm going to finish off by adding the ending parentheses. Now, it's always important to check. This check doesn't necessarily need to be written out on paper. I'm going to write that out today just so we can see it visually. But it's a good idea to check in your head that your expressions are equivalent, that they mean the exact same thing. That way you can know, before even turning in this worksheet to me, whether you have 100 on it or not. Because you should be able to check that each of the expressions are equivalent or equal, and if they are, you know you did a great job. So 20 plus 8 is pretty simple. Again, I could do this in my head and get 28. If I look at the opposite side of the equation, I would do what's in the parentheses first. 5 plus 2 is 7. So I can do that in my head, and then 7 times 4 is 28. I can do that in my head. So I know that I correctly used the reverse distributive property, and that 4 times 5 plus 2 is going to be equal to 20 plus 8. If you feel confident with these steps, go ahead and try the next one on your own. Otherwise, follow along as I go through. Again, I'm going to start out by finding the GCF, and if you think you know or you're able to see that GCF without showing your work, go ahead and try that. Otherwise, I really encourage you to show your work just to be sure. So I'm going to put 24 and 18 under my birthday cake. I'm going to notice that 2 again goes into both of those. I like even numbers a lot. 2 goes into 24 12 times and into 18 9 times. When I look at both these numbers, I know that 3 is a factor of both. So 3 is going to go into 12 4 times and into 9 3 times. 4 and 3 share no common factors. The factors of 3 are only 1 and 3, so the only one of those that'll be comparable to a factor of 4 is going to be 1. So now I can find the product, and I notice that 6 is going to be my GCF. Again, I'm going to put the 6 outside of my parentheses. My next step is going to divide 6 into each of those numbers. So 6 into 24 goes in 4 times. 6 goes into 18 3 times. Since my original problem had a subtraction symbol, I'm going to place a subtraction symbol here, and I'm going to end with my parentheses. Then again, I'm going to go back and I'm going to check just to be sure. This can be done quickly inside my head, or I can write it out like I'm going to do here so that you can see visually what I'm discussing or how I'm checking. So I'm just going to check that these are equal. So if I do 24 minus 18, I get 6. If I check the other side, I do order of operations, so what's inside parentheses comes first. It's going to be 4 minus 3 is 1. 6 times 1 is going to be 6. So since 6 and 6 are equal, they're equivalent, that tells me that my expressions are equivalent and that my answer would be 6 times 4 minus 3 in parentheses. Go ahead and try the additional problems on your practice, and we'll review and go over these two concepts tomorrow.